Hello everyone, October 19th. Alright, let's do this. No, that's yesterday's. Sorry. Parsing a Boolean expression. A Boolean expression is an expression that evaluates to either true or false. It can be one of the following shapes. T, that evaluates to true. F evaluates to false. Not something evaluates to the not. And something evaluates to the logic and of the inner expression, where n is logic equal to 1, or is the logic or. Given a string that represents a Boolean expression, return the evaluation of that. It's guaranteed that the given expression is valid and follows the given rule. So in this case, we have f, and then we evaluate not f, so it's a t, and an n, so it's going to be oh, it's not a not. Oh, sorry, I thought it was a not. No, it's an or. So it's f, and it's f. That's a t. Interesting. I'm thinking whether a stack will work in this situation, because we always have something and then something. So the innermost is always going to be t, and then you have basically 3 different evaluations. So we can, let's say, scan it. We have something, and then we have, and it says it's always going to be valid, which means if you have a parentheses, you will definitely have a right parentheses, right? So maybe we'll have 2 pointers, one at the front, one the other at the end, and we will evaluate from the front. All right, we evaluate from the front. Hold on, let me just do a little bit experiment. For example, if I do this, is this considered valid? It's considered invalid. Right, if I do this. So this basically means it's always going to be a single parentheses. So if I have 2 pointers, one on the left and one on the right, and I check the one on the left, then I will know what it is, right? And then I move it in, move from right in, then I can extract this part. I say, give me this value, right? And I'll evaluate this value. Once it's evaluated, I'll check the current operator, right? Okay, so this one will work. But in this case, I'll have this. And if the start is not a operator, then it has to be either a true or a false. Then what we can do is we'll return. Oh, that's hard to return. What are you going to return? We have to figure out a return. Maybe we can use a system of return an integer. Right? We return 1. A 0 means everything is false. 1, everything is true. And 3 and 2 is we have a mixture. Therefore, this will return a 0. And then when it turns 0, my operator is an OR. It sees a 0, it will return a 0. And its AND sees a 0, return a 0, right? In this case, there's no operator, and then we just, we check it's not an operator. Then we know it's either, and its length is now 1, right? And then we will just go through the whole string and then count. Yeah, count the number of F and the number of T's, right? Count the number of F and the number of T's. Yes, it's actually regardless. We'll count, and then they'll give me the count. Okay. Yeah, let's give this idea a shot. Maybe it will work. And what I also don't know is whether this might be. No, I don't think so. Alright, anyway, we need to do a private int recurse. We call it helper. That'll be easier to deal with. So what we do, we need expression, right? We also need low, high. Okay, we can say return 0 if the evaluation is all F. Return 1 if the evaluation T. Return 2 if the evaluation mixture of T and F. Okay, so that's basically what we have. And then we have a low and have a high. Then we say if expression dot char at low is equal to F or expression dot char at high. No high. Hold on. It's not high. Still low is equal to T. Right? Must be a not an operator, right? Not an operator. So in this case, we basically just count, right? Count T is 0, count F is 0. For int I equal to low I smaller equal to high, I plus plus. If expression dot char at low, not low, I is equal to T, count T plus plus. Else if expression dot char at F, not F, I is equal to F, count F plus plus, right? And then we say if count T is larger than 0 and count F is larger than 0, then we just break. We don't have to keep going. Right, we don't have to keep going. But if we only have one, yeah, so we do that, then we will get out and we say if count T is larger than 0 and count F equal to 0. This same situation, we return 1. If count T is equal to 0 and count F is larger than 0. In this situation, we return 0. And the last situation, we return 2. Okay, that's that. And currently under an operator. So what we can do is we'll say int inside shall equal to helper expression low plus 2 because the current, the front, right? So low plus 1 plus 2, high minus 1, right? And then if expression dot char at low is equal to not if it's a not, then we shall return whatever inside but the inverse. So inside exclusive or 1, right? If it's a 1, it becomes a 0. If it's a 0, it becomes 1. If expression dot char at low is equal to an and, right? So return inside if it's equal to 2. If it's an and so f. So the only situation we'll return true is if everything is true. So if it's equal 1, then we'll return 1. If it's not 1, it's 0, or if it's a 2, we will return 0, right? Okay. And last situation is return, yeah, we just return inside is equal to 0, then we return 0, otherwise return 1. All right, this is a current operation. Operator is or. Wait, where's or? Okay, and then here we're gonna say int res is equal to helper expression 0 expression dot length minus 1. All right, we shall return res equal to 1. If it's a 1, that's a true. If it's 0, that's a false. Okay. Okay, let's take a look. Let's see, I'm not sure if it's going to be right, but 1106. Recursively solve each operator. Use a marker to indicate whether the next level returns all T, all F, or a mixture of T and F. Then, based on the operator, we produce the result of the operation. I think it's ON because we basically go through everything, and then since it's valid, I think it shall work. Oh, old problem. It was right the first one. Oh, I forgot about this situation. Damn. Okay, that was an oversight. It could be an operator and then a thing. Okay. So yeah, operator, we have a count, and then okay, my bad. I did not consider the situation. Absolutely did not. Okay, so this one does not work. 5 years ago. Okay. Then we probably need to, okay, so this is, and then we put a left parentheses and left parentheses. Okay, and then we have T, F, we have a T, and then comma, let's say I don't consider, F, okay, now we start a counter, and then T again, okay, so now I have 2 T's, 1 F, right parentheses. Now it's a T, we don't even have to put it, it's just a T, we put in a counter, F we put in a counter, T we put in a counter, right parentheses, I have TFT, and as in the right parentheses, we will, I actually don't even need to put the left parentheses, right? And then right parentheses, I just check, pop this as end, I have TFT, so this time it's gonna be an F, so we wipe out the counter, we check the false equals 0, next one comes in, okay, so change the idea, yeah, this is not gonna work because yeah, it's not gonna work. Alright, so completely change the idea. So now what we're gonna do is use stack. Okay. So what we're gonna do is stack character stack new stack. Okay. And then int count t count. Okay, and then for char c of expression dot char, okay, if c is equal to t, then count 1 plus plus. Else if c is equal to, maybe we can use switch. C, we say if it's a t, then count 1 plus plus. And then case f count 0 plus plus. Case case left parentheses, and then case comma continue, case and case or case not, stack dot add c break. Oh, basically we just do break, right? Because these we should break. Then I don't even need these. So I check this or break, check this or break, check these or break, and the most important is case right parentheses, right? So case right parentheses, what do you think? So if it's the case is right parentheses, then we need to pop out the operator. Right, when they pop out the operator. Pop out the operator. Can say if stack dot is empty. Right, if stack is not empty, char op is going to be stack.pop. Okay, so operator is out, and right, operator is out. We say if so I need to operator's out. Okay, so based on the current we'll get, okay, that seems to be a function to me. Private, but what you gonna return? We return a new counter. Right, we return a new counter. So we say this operate char operator count. Yeah. So if switch op, if operator is and, right? We can void it. Update in place. Count in place. Okay, so basically we say if count 0 is larger than 0, we have at least one f, right? Then count 0 equal to 1, count 1 equal to 0. Else count 0 is equal to 0, so there's no false, only true. Then count 0 equal to 0, count 1 is equal to 1. Okay. Case or if count 1, we have 1 true, count 1 is equal to 1, count 0 is equal to 0. Else we don't have any true, so it's going to be false. Okay, and break case this. If count 1 is larger than 0, count 0 is equal to 1, count 1 is equal to 0. Else, isn't this the same as or? Oh, no, it's not the same as or. It's not the same. So else if count 0 larger than 0. 0 is equal to 0, 1 is equal to 1. Okay, we'll update this and then this will break. So it's a void. Okay, I can do immediately, we will say operate stack.pop and then count. Okay, stack not empty. Then we'll do this, then we'll update the count. And then we continue. So we'll do that. Oh. Okay, and at the end, we'll say return count 0 larger than 0. That will be a false, otherwise it will be true. Yeah, actually, I think, yeah, I'll just do it this way. Okay, let's try this. Get these one pass first. Then we throw in a new one. Then we'll try it. Looking good. Try it again. Still not right. So in this case, I count a false, and then I count, and then I do a, oh, okay, so this one is wrong. I should not reset. So basically, I shall say plus equal to 1, right? I don't change, I do not reset. If the current, because we are doing operation, yeah, we're doing an operation. Oh, but that is not right. That is not right. I need an okay, we're doing an operation, but I need to know. Because I already have f, right? I have f, and then I have a and. And then we come a new t. Then I actually need a new set of counter. So I always set this, and I will do this. Okay, so a little bit different. Hold on. Yeah, it makes sense. So basically, we don't use we use a stack of counters. Each counter will go with one operator. So we have a stack for operator, and I'll have a stack for counter. That makes more sense, honestly. We have a stack for operator and a stack for counter. So when the operator is currently doing, we use its associated, right? We use its associated counter. Okay, and then we'll count, and then we'll do that, and then we'll have a new counter, right? After operation, and that one need to be merged into the previous, unless there is no previous. What if there's no previous? Then we have an original, right? We have an original. We always put something in the stack. Then we have original, right? So we can put something in. So we can always merge it in. Okay, so so stack dot add. Okay, we don't call it stack operator. Dummy. Same thing. We say stack. Stack count. This is technically this is not a dummy. And then we go through this, right? Every time we have one, we just say stack count dot peak 1 plus plus. Okay, and then this is gonna be stack count peak 0 plus plus, right? So we always add the most recent. And then if this happens, then stack OP and stack count. Okay, and if this stack OP is never going to be empty, then we just operate int new count. Stack count dot pop. Right? So we pop both, get a new count. Peak cannot, oh my god. Okay, so we're gonna go up. New count. Oh, these are not, these are old counts. Alright, so old count, the new count. Old count, new count, old count, new count. So at the end we'll return. I mean, technically we can return there. Yeah. Let's not do it this way. Technically we can return new int 1 0, right? This is return new int 0 1. We can say return count 0 is larger than 0, and then we say new int 1 0 or new int 0 1, right? D4. Same thing, return count 1, new int 0 1. Actually, we can just do this, it's fine. Because it says it follows the rule. Unreachable code. Cool, so we can just do this. Should not reach here. Okay, so that's operate. So we come here, we get a new count operate. And once we have a new count, we merge into the previous count, right? So we say stack count dot peak 0 plus equal to new count 0. Stack count dot peak 1 plus equal to new count 1. We update it, and that's it. So at the end, we'll do stack count dot peak. Ooh, but we need to pop. Oh, we do pop. We pop until so dot peak. All right. So use stack one stack to track the operators, and the other stack to track the number of T's and F's under each operator. We also use a dummy operator up front to capture any T and F not belonging. Stray T's and F's. Okay. That'll be interesting. So this is an interesting new idea. Let's put this one into test. See if this one works. It works so far. Submit it. Yep. It's pretty good. This idea works. Took a 3-shot. I'm interested in how I solved it last time. Huh. Symbol. TF. Oh yeah, this is actually very easy. Well, the TRF exists in the expression. So we have a counter, and then, well, the top is not the left. TF this equal to 1. I don't even have the count, it's just existence. Pop that parenthesis operator. Put it back, put it back, put it back, put it back. Yeah, I think it's easier than what I did. I don't know. I was thinking, oh my god. That was just for fun. Okay, so I mean, yeah, we solve it in this using this, but apparently it's I think it's not the best idea. It's a little bit convoluted. Okay, let's try another one. So this is gonna be this is the solution from myself 5 years ago. I think it was better than the one I'm using this time. The counter yeah, you just put it in, and then you just do, right? Right parentheses, we start popping. Yeah, I don't know why you don't use that. So we just need a character stack, right? And then char c of expression dot char array. If c is equal to this, or c is equal to left parentheses, so we actually don't need left parentheses as well. Continue. Otherwise, if c is equal to right parentheses, this is where things become real, so I'll do it later. Else, we just do stack dot add c. Okay. Boolean has t false. Yep. Int tf while stack dot is now empty and stack dot peak is equal to t, or stack dot peak equal to f. Okay, so I think it'll be better to do that. Then stack will pop it, and then we'll say 0 and 1, right? Stack dot pop equal to t, then tf left shift equal to tf or 1 left shift to 1, right? 1 left shift 1, which is 2, right? So we can just do or 2 tf or 1, right? 0 and a 1, just in case. Just in case. Because I'm not sure about the operator preface. Wow, 1 line. Okay. Alright, so we get rid of all of them. We have a tf, and now we get to the operator. Then we say switch. Stack dot pop. Alright. If it's this, stack dot add based on tf, right? We can say tf is equal to, it's not gonna be 2, so it's just 0, right? If it's 0, no, it's either 1, 2, or 3, right? So if it's equal to 1, then we will put a 1 is gonna be an f. Oh wait, hold on, it's gonna be a t. Otherwise it's gonna be f. Right. So tf equal to 1, that we have use bit manipulation. Right? Wait, let me try put it here. Bit manipulation. 1 only f2 only T. 3 mixture. So 1 only F, so we become T, right? So case or stack.add tf equal to, as long as has, so 2 or 3, so if it's 1 only F, so we do F, otherwise it's going to be T. Break. Next one, case and stack.add tf equal to 2, then we do a T, otherwise we do a F, and then we'll break. Okay, so this is the stack. Pop it, we do this, done. Otherwise we add it, and then at the end of return stack.pop. Yep, equal to T. Oh, I think this is much better. I do believe this is much better. Oopsie doozy. Yep. Oh! Oh, it takes longer. Huh. I am not sure why it takes longer. Well, it takes longer because there's a lot more push. Right? There's a lot more push. But I don't know. But I like this one better. I like this one better. String manipulation. Recursion. We were trying recursion, but it didn't really work for us. And I abandoned the idea. And apparently you can use recursion. How do you use recursion? I guess you can use recursion. I mean, stack, essentially it is recursion, right? Yeah, it is recursion. So yeah, I think you can use recursion, yes. But I feel stack is a much simpler way of dealing with this. Optimize the stack. Where did you optimize it? Space complexity, time complexity. I don't see an optimization. Well, you did make the code look a little bit easier, but I don't think it's any easy. I think this is pretty easy, right? Pretty straightforward. Yeah, it's actually pretty easy. I have to admit. I don't think this is a hard one. Well, anyway, so my solution today was, I don't know. I used two stack for this. I didn't realize I can push it back in. It's something I was not thinking. And then the second one, I used a little bit manipulation to handle this. Yeah, I like this one better. This one just straightforward. You don't have to deal with two stacks, and then you have to keep track. Yeah, this is actually not necessary. Yeah, you're not necessary to do this. So this one can be a little bit easier. Oh, hold on. Oh, I see the difference. I see the difference. Why this one performs better? Because this one does not have, because if you use stack, right? If you use this one, you have this pop thing going. You have to push the T and Fs, right? And then you have to pop them. So the T and Fs have to go twice. But this solution, the T and Fs don't go twice. The only things that do go twice is the operator. Because I have a push on operator, right? You have a push on operator and you have a pop on operator. But the TNFs, so you can have gazillion number of TNFs, it will be fine because I put them into this array. Now that I'm thinking about it, I don't even need to use an array, right? Oh boy, I think we can make it even better. This can be just an integer. This can be just an integer. All right, so we just do 0, and then we can just say each integer is a bit state where I'm just gonna do it again. 1 is only f, 2 is only t, and 3 is mixture. All right, so I don't need to do this. I just need to do or, because it's a t, right? It's a t, so we will or 2, right? If it's an f, then we say this or 1. Oh wait, hold on. Or equal to, right? Left hand side assignment must be a variable. Oh wait, hold on. It's not a variable. Wait, what? Left hand side of an assignment. Oh, shoot! You have to pop and push. Oh man. Oh man. Oh man. I want to. Damn it. If you want to pop and push, I'm not sure if it's saving anything. Aha, you have the pop and push. I don't think it's saving anything, honestly. No, I don't think so. I don't think so, because you have to do stack count dot add stack count dot pop, or do something like this. Well, we are on this. So this is going to be 1 because it's a false. We'll do another 0, right? And then this will give us the state, right? New state is going to be operator state. Okay, so char, and this does not say count state. And then this is not this. So if it's end, and we shall return the state. Yeah, state if it's true, all true. So 2, right? State is equal to 2. Then return 2. Otherwise, return 1. Does make it easier though. I have to admit. So again, states this must be 1. 1 is a false. So if it's a false, it will be a false. Otherwise, it will be a true. If it's this, actually we can consult. Yeah, 1, 2, T, 1, F, right? 2, T, 1, this is F. And if it's this, we shall return state is equal to, we can say true. This is a false, right? If it's false, then we'll return true. Otherwise it will return false. Yes, if it's a false return, okay. Default, we do have to return something. Or return 0. Now I feel like you don't need to call a function. But actually it's fine, we can call a function. And then there's a new state. Oh shoot. And then we shall say stack count. I shouldn't call it stack count. Dot add stack count dot pop, whatever it is, and we will or this new state. And then at the end, we'll say stack count dot pop. So it's gonna be 1 or 2, right? If it's equal to 1, no, it should be equal to 2. 2 is true, 1 is false. Alright, one last thing. Instead of calling it stack count, I'm gonna call it stack state. Okay, stack state. Okay, let's try this. Should be right. Just use a slightly different way of addressing it. Maybe it'll be even faster. Let's see. This is 8. But we do have a lot of push and pop. 9. So we save time on not having to create an array, but we also waste time by doing a lot of push and pop. So yeah. But that's okay. All right, that will be it. I will see you guys. I just realized it could be one more optimization. We have 2 stacks, right? We can combine them as a 1 stack because I just need an integer. So this can be an int array. So we only handle 1 stack. And there's no push and pop. Damn, there's another way. Oh, I am very intrigued. I think there's one more way to make it even better. Well, we know it will make it better. But yeah, so we'll leave it for another day. All right, I'll see you guys tomorrow. Adios.